All right, this lesson is going to be a continuance of trigonometry dealing with angles of elevation and depression. These are going to bring in word problems. First, the warm-up wants us to solve the triangle. What we need to make sure we read carefully is that we're going to round the side lengths to the nearest tenth and the angle measures to the nearest whole degree or whole number. We talked about how to solve the triangle here. We'll go ahead and what we're going to do is to find the missing side of GJ. We're going to actually, you can't use trigonometry because we don't have a reference angle. So we have to use Pythagorean theorem. So here with our a squared plus b squared equals c squared, we're going to be looking for c, the hypotenuse. So we'll plug in 21 squared plus 36 squared equals c squared. Square our numbers. 441 plus 1,296. We're going to add them together to get 1,737, all equal to c squared. Please make sure you're bringing that c squared down. If we don't, we're going to get the wrong answer because we're going to forget that we have to now take the square root. So when we take the square root, because I know usually with Pythagorean theorem in our class, we've been lately going to the simplest radical form, but this one does want the side lengths to the nearest tenth. So this one's going to end up being 41.7. And I'm just going to go ahead and put GJ here. Now, when we want to find these angles, we can find angle G and angle J not even using this 41.7. We're going to do this by using our reference angles. So here, let's go ahead and take a look at the finding angle G. So right here, we're going to go ahead and see that we're going to be using from angle G, the reference angle or angle of perspective, we're going to be using the opposite side and adjacent. So that's going to tell us that we're going to use tangent or TOA. So we'll plug in the tangent of, I'll just put G because that's the angle we're looking for. This will be equal to opposite 21 over adjacent 36. So on the Desmos scientific calculator, in case there are people watching this that don't have the calculators we have in our classroom, the Desmos scientific calculator here, we're going to need to, because we're looking for an angle, we're going to have to do the inverse of tangent, or the inverse tangent of 21 over 36. So we need to go to the function button on the Desmos scientific calculator. We're going to press the inverse tangent, and then we're going to go back to the main menu. I'm going to type in the a over b to get my fraction function. We'll type in 21. I'm going to tap on the denominator here and type in the 36. And then we have our measurement. We are rounded to the nearest whole number, so it's going to be approximately 30 degrees. I'm going to go ahead and switch colors so I can switch my reference angle. Now, to find the measurement of angle J, here's our reference angle. So now we're going to have 36 is going to be the opposite, and 21 is going to be adjacent. So we will still use tangent or TOA. So we'll have the tangent of angle J is going to be equal to, here, opposite 36. Over adjacent 21. We need to do the inverse, so we'll have the angle J inverse tangent with the -1 exponent of 36 over 21. So again, on the Desmos, we're going to go to the function button, inverse tangent back to main, my a over b, and we'll type in the 36, go down to the denominator and type in the 21. And we're going to find out nearest whole number is going to be approximately 60 degrees. Let's go ahead and talk about our angle of elevation and depression. First, we need to look at the line of sight. The line of sight is going to be the line that's connecting the observer or the object to another object. So right here, this is going to be a line of sight. Okay, these solid lines. Where are you looking? I'm looking at the bird. My eyes are going to that bird. Or my eyes are going downward towards the fish. The angle of elevation is going to be an angle formed by an upward line of sight and horizontal line. What that means here is, here's your horizontal line. The line of sight goes upward, creating an angle of elevation. Think about it. I know an elevator goes up and down, but the big reason for an elevator was so you don't have to take 52 flights of stairs up. So your elevation going upward. Your angle of depression is going to be the opposite. It's going to be a downward angle. So your angle of depression is going to go from the horizontal line looking downward at the fish. So you think of depression, when you feel a little depressed, you're feeling a little down. So there's angle of depression. So in this next diagram, we're going to go ahead and label our angles of elevation and angles of depression. So we're looking at right here, we're saying here's your horizontal line. Whenever we go downward, here's your line of sight. Your line of sight is always going to be the diagonal. We're going downward, so this would be an angle of depression. If we're down here, and here's our line of sight, here's the horizontal line, our line of sight is going to go upward, we have an angle of elevation. And then we're going to see over here, we're just reflecting over here. So now we're going to be looking towards the left. Here's the horizontal line, and we're going to go downward. Here's our angle of depression. And then if we're standing over here, here's the horizontal line. We're now going to look upward, angle of elevation. I want you guys to also note here, your angle of elevation and depression will be congruent. The reason why is these horizontal lines are parallel, and this line of sight is going to be the transversal. So here we have alternate interior angles. So that is why angle of depression, angle of elevation, each problem is going to be congruent. The other thing we're going to discuss here, it's, well, actually exactly what I just said. The line of sight is going to serve as a transversal. So the angle of elevation and depression are going to be examples of alternate interior angles. And these horizontal lines are parallel, making the angle of elevation and depression congruent. So we're going to have 4 problems, word problems. You guys are going to get to see some of my beautiful drawings here and how great of an artist I am. Usually when we're dealing with finding angles, we'll be rounding to the nearest whole number. With this one, everything that we're finding, whether it's side or an angle, this is asking us to round everything to the nearest whole number. So let's go ahead and talk about this first problem. We have the Seattle Space Needle is going to cast a 67-meter shadow. So right here, I'm going to go ahead and have my Space Needle, beautiful drawing. Its shadows are going to be on the ground, horizontal, is going to be 67 meters. The angle of elevation from the tip of the shadow all the way over here to the top of the Space Needle. So here's our line of sight. The angle of elevation will be right here. It's going to be 70 degrees. We want to know how tall the Space Needle is. What I do want to do here is make sure we highlight elevation and knowing that we're going to be going up. So how tall is the Space Needle? That's going to be right here. So what we'll go ahead and do is set up our trigonometric function and solve. Here's our reference angle. Looking at that, I know it's kind of hard to see, but this is going to be a right angle. We're going to notice we're not using our hypotenuse. Okay, so we're going to start our angle of perspective, or reference angle. We're going to see x is going to be the opposite side, and 67 will be adjacent. So we will be using tangent. Almost all word problems with angle of elevation and depression will be tangent, but not all, and we'll see that here in a minute. So let's go ahead and set up our equation. We have the tangent of 70, our angle measurement, will be equal to, we want opposite, x over adjacent 67. What I have taught my students, and it's mentioned in my previous videos, is find x. Where is x? If x is in the numerator, we're going to multiply. No, it's not n, or mm, but n and m are right next to each other in the alphabet. Where is x? Numerator, we're going to cross multiply. So this will end up being x equals, I always suggest putting the whole number first. We don't accidentally put it in the parentheses on our calculator. 67 times the tangent of 70. Showing in that Desmos calculator here, we're just going to type that in. And when we're not doing inverse, it's great because we don't even have to go to a different window here. We can just go ahead and type in tangent. Oh, sorry, we need the whole number first, 67 times the tangent of 70. Rounded to the nearest whole number, 184. So we have 184 meters. All right, next story. We've got a pilot of a helicopter. Let's see this beautiful drawing. Gorgeous. I know, I should have my artwork in the museum. He's going to be up in the air, okay? He's tracking an accident on the ground. So keep in mind, here's your horizontal distance, okay? And we've got this little accident down here, okay? Here's just a wreck, right? Just a mess. His line of sight, right here that I just drew crooked, the angle of depression, meaning downward from the horizontal line, right here, is going to be 18 degrees. Now, we want to know we have that the helicopter's altitude is 1,560. That means how high up in the air he is. So right here, our vertical distance is 1,560. We want to know the horizontal distance, right here, from where the helicopter is hovering above to that accident. Here's our 90-degree angle, and here's x. So with this angle of depression, we need to remember that it is going to be congruent to this angle of elevation. So this will be 18 degrees as well. Now that we have that, we can go ahead and take a look at what we have here. Let's sit right here at our reference angle. We're not using our hypotenuse, automatically tangent. The 1,560 is on the opposite side. The x is adjacent to our reference angle. So we'll be using tangent. And we'll set up our equation. Tangent of the angle 18 is going to be equal to opposite 1,560 over adjacent x. And the shortcut without doing proportions for this is where is x? If it's in the denominator, we divide. We're going to switch these two around. X is going to move over here to the left. Tangent is going to move, here's 1,560. Tangent's going to now replace x in the denominator. And then in our calculator, we can go ahead and start off with the a over b fraction function. We'll put 1,560 in the numerator. Go down to the denominator and type in tangent of 18. Rounded to the nearest whole number, we have 4,801. And that's feet. All right, next story. Okay, we have a flagpole. And I'm going to go ahead and draw the ground. It's always going to be 90 degrees to the ground. We have an 8.7 meter wire attached diagonally, and I'll tell you diagonally as well, but a wire generally is going to be that diagonal, the hypotenuse, diagonally from the top of the pole to the ground. The pole is 7.4 meters tall. So here's the height. What is, oh sorry, 8.7, the wire is 8.7 meters. What is the angle of elevation to the top of the pole? Angle of elevation tells us we're going to go upward. So on this triangle, we're going to start at the ground and we're going to look upwards. So here is your angle of elevation. We don't know it. So this is going to be theta. Okay, we need to remember theta, that Greek letter for our missing our angle of perspective. So let's go ahead and figure out which trigonometric function we're using. Here's our reference angle. I always tell my students, label your reference angle and check the hypotenuse first. Here we are going to be using the hypotenuse, and the other side we're using is on the complete opposite side of the triangle. So O and H is going to give us sine opposite over hypotenuse. So let's go ahead and set this up. We have the sine of theta, if you'd like to put x, that's fine, is equal to opposite 7.4 over hypotenuse 8.7. When you're looking for a missing angle, we need to do we did this twice in the warm-up. We need to go ahead and do the inverse. So we're going to have theta equals the inverse with the -1 exponent of 7.4 over 8.7. Rounded to the nearest whole number, again with the calculator, we're going to go to the function button, go to the inverse sign, back to main, A over B. We're going to go ahead and type in 7.4 over 8.7. Rounded to the nearest whole number, this will be 58 degrees. All right, last story. We've got a ship sailing, so we've got the water. Okay, here's our little ship. I already know it needs to be at the top because we're going to have angle of depression. So here's the water. This is going to be the horizontal line. It's going to be, the ship is going to be 3,280 feet above the ocean floor. So here's the ocean floor. Here's the height above it, 3,280. He's going to notice a sunken treasure. So I'll put a dollar sign. We got some treasure down there. And it's saying the horizontal distance from where the ship is to this treasure, it could be either up here, it's going to be the 4,000 feet. What we need to realize is these are going to be the same. The horizontal distance will be the same whether it's above or below. So this will also be 4,000. We want to know what the angle of depression is from the boat to the sunken treasure. So here's our diagonal. We want to know this right here. Remembering that your angle of depression, we'll go ahead and highlight that and put down. Your angle of depression from the ship to the treasure and the angle of elevation from the treasure to the ship are going to be the same. So this, we can just look for this angle right here. So let's go ahead and look at what we have. We have our reference angle. We will not be using the hypotenuse. So from our angle of perspective or reference angle, we're going to go to the opposite side and label that O and the adjacent A, telling us we're using TOA, tangent. Set up our equation. The tangent of theta is equal to opposite 3,280 over adjacent 4,000. You can simplify the ratio if you'd like to, but you don't have to. Because this is inverse, or sorry, just for finding the angle measurement, we need to use inverse. So we'll go ahead and take the tangent and move it to the right as the inverse of -1 exponent of 3,280 over 4,000. Back into that calculator. We'll go ahead and go to function, inverse tangent, back to main, A over B. We'll type in 3,280 over 4,000. And we wind up to the nearest whole number, 39 degrees. And those are your angled elevation and depression word problems and my beautiful drawings.